Imagine for a moment that you are the fastest thing in existence. You are a photon, a particle of pure light, racing through the cosmos at 300,000 kilometers every single second. Nothing in the entire universe can travel faster than you. You are the ultimate speed limit of reality itself, the cosmic Ferrari that everything else can only dream of becoming. And yet, here is the terrifying truth that will haunt you for the rest of this journey. Even you, the fastest possible thing, are trapped. You're imprisoned in a cosmic jail that has no walls, no guards, no physical barriers of any kind. There are no chains holding you back, no force fields blocking your path, no mysterious energy preventing your escape, and still, you cannot leave. You will never leave. No matter how long you travel, no matter how determined you are, no matter how much time passes, you're stuck forever in a bubble of reality from which escape is mathematically, physically, and fundamentally impossible. Welcome to the observable universe's horizon. Welcome to the most beautiful prison ever conceived by nature. Welcome to the edge of everything you will ever know, see, touch, or influence. And today, we're going to explore why this prison exists, how it works, and what it means for you, for humanity, and for the fate of everything that has ever existed or ever will exist. Before we dive into this cosmic mystery, let me share with you some facts that will shatter your understanding of reality. Fact number 1. Right now, as you watch this video, you are moving away from distant galaxies at speeds faster than light. Yes, faster than light. And no, this does not violate any law of physics. It is perfectly legal, perfectly allowed, and perfectly terrifying. Fact number 2. There are galaxies in the night sky. Galaxies you can see through powerful telescopes. Galaxies whose light is reaching your eyes at this very moment that you will never ever be able to visit. Not in a million years, not in a billion years, not if you had infinite fuel, infinite time, and infinite determination. They are visible but unreachable, like a mirage that exists but can never be touched. Fact number 3. The edge of our observable universe is not a place in space. It is a moment in time. The horizon is not a wall you could bump into if you traveled far enough. It is the boundary of causality itself, the limit of what can ever affect you or be affected by you. Fact number 4. There is light traveling through space right now. Light that left distant galaxies billions of years ago. Light that is desperately trying to reach us, and it never will. It will travel forever, racing toward us at the fastest possible speed, and yet it will fall further and further behind like a runner on a treadmill that speeds up faster than they can sprint. Fact number 5. The observable universe is simultaneously getting larger and smaller. We can see more of the universe as time passes because more light reaches us, but we can interact with less and less of it because expansion is carrying everything away. Our cosmic kingdom of visibility grows, while our cosmic kingdom of influence shrinks. Now, if these facts made your brain hurt a little, good. That means you are paying attention. That means you're ready to go deeper into the rabbit hole. That means you are prepared to question everything you thought you knew about space, time, distance, and the nature of reality itself. So let me ask you a question that will frame our entire journey today. What kind of prison has no walls? What kind of jail needs no guards? What kind of cage requires no bars, no locks, no physical structure of any kind, and yet holds its prisoners with absolute unbreakable certainty? The answer is a prison made not of matter, but of the fabric of space-time itself. A prison whose walls are woven from the expansion of the universe. A prison whose locks are secured by the speed of light. A prison whose sentence is eternity, with no possibility of parole, no hope of escape, no chance of ever seeing what lies beyond. If you find this fascinating, if you want to understand the deepest truths about the cosmos we inhabit, then stay with me. Subscribe to this channel and hit that notification bell because what we are about to explore will fundamentally transform how you see the night sky. Leave a comment below telling me what you think the most mind-bending aspect of the cosmic horizon is. Share this video with anyone who has ever looked up at the stars and wondered if there is a limit to how far we could go. Because by the end of our journey together, you will have the answer, and that answer will be both humbling and magnificent. Let us begin at the beginning. What exactly is the observable universe? This seems like such a simple question, but the answer contains layers of complexity that most people never consider. The observable universe is not the same thing as the universe itself. This is the first and most important distinction we need to make. The universe, the actual totality of everything that exists, might be infinite. It might stretch on forever in all directions, containing an endless number of galaxies, stars, planets, and possibilities. Or it might be finite but unimaginably vast, so large that the part we can see is like a single grain of sand on an endless beach. We do not know which is true, we may never know. But what we do know is that we can only see a portion of whatever exists, and that portion is called the observable universe. The observable universe is defined by light and time. It is the sphere of space from which light has had enough time to travel to us since the beginning of the universe. Think about what this means. When you look at a distant star, you're not seeing that star as it is now. You're seeing it as it was when the light left it. If a star is 10 light years away, you're seeing it as it was 10 years ago. If a galaxy is 1,000,000 light years away, you're seeing it as it was 1,000,000 years ago. The further you look into space, the further you look back in time. Space and time are inseparably linked in this cosmic dance of light and distance. Now, the universe is approximately 13.8 billion years old. The Big Bang occurred 13.8 billion years ago, and that was the moment when time itself began, at least as far as we can currently understand. So you might think that the observable universe should be a sphere with a radius of 13.8 billion light years. After all, light travels at 1 light year per year by definition, so in 13.8 billion years, light should have traveled 13.8 billion light years. Simple math, right? Wrong. The observable universe has a radius of approximately 46.5 billion light years, giving it a diameter of about 93 billion light years. Wait, how can that be? How can we see things that are 46 billion light years away in a universe that is only 13.8 billion years old? This apparent paradox is the doorway to understanding why nothing can escape the cosmic horizon, and its resolution lies in one of the most mind-bending aspects of our universe, the expansion of space itself. Space is not static. Space is not a fixed stage upon which the drama of the cosmos plays out. Space itself is dynamic, alive, constantly changing. Space is stretching, growing, expanding, and it has been doing so since the very first moment of existence. When light left a distant galaxy billions of years ago, that galaxy was much closer to us than it is now. As the light traveled through space toward us, space itself was expanding. The galaxy was being carried away by this expansion, even as its light raced toward us. So when the light finally arrives at our eyes after billions of years of travel, the galaxy that emitted it has been carried much, much further away. That is why we can see objects that are now 46 billion light years away in a universe that has only existed for 13.8 billion years. The light left when they were closer, traveled through expanding space, and the objects themselves were carried to their current enormous distances by that same expansion. This is the first key to understanding the cosmic prison. Space is expanding, and that expansion is carrying everything in the universe away from everything else. It is not that galaxies are flying through space like rockets blasting away from each other. The galaxies themselves are largely stationary relative to the space around them, but the space between them is growing, stretching, increasing. Imagine dots on a balloon. As you inflate the balloon, the dots move apart from each other, but not because the dots themselves are moving across the surface of the balloon. They are being carried apart by the expansion of the balloon itself. This is analogous to what is happening in our universe, though the reality is far more complex and profound than this simple analogy can capture. The expansion of space was first discovered by Edwin Hubble in the 1920s, one of the most revolutionary discoveries in the history of science. Hubble observed that distant galaxies are moving away from us, and more importantly, he discovered that the farther away a galaxy is, the faster it appears to be receding. This relationship is known as Hubble's law, and it can be expressed with elegant simplicity. The recession velocity of a galaxy equals the Hubble constant multiplied by the distance to that galaxy. The Hubble constant, which represents the current rate of expansion, is approximately 70 kilometers per second per megaparsec. This means that for every megaparsec of distance, which is about 3.26 million light years, galaxies are moving away from us about 70 kilometers per second faster. Let that sink in for a moment. A galaxy 1 megaparsec away is receding at about 70 kilometers per second. A galaxy 2 megaparsecs away is receding at about 140 kilometers per second. A galaxy 3 megaparsecs away is receding at about 210 kilometers per second. And so on, increasing linearly with distance. Now here is where things get really interesting. The speed of light is about 300,000 kilometers per second. If the recession velocity increases linearly with distance, then at some distance, galaxies must be receding at the speed of the light, and beyond that distance they must be receding faster than light. This distance is called the Hubble radius, or the Hubble sphere, and it marks a crucial boundary in the cosmos. Beyond the Hubble radius, galaxies are being carried away from us by the expansion of space at speeds exceeding the speed of light. And this does not violate Einstein's special theory of relativity. This is incredibly important to understand. Special relativity says that nothing can travel through space faster than light. But it says nothing about space itself. Space can expand at any rate whatsoever. And when space expands, it can carry objects along with it at any speed, including speeds greater than light. The galaxies beyond the Hubble radius are not moving through space at faster than light speeds. They are being carried by the expansion of space itself, and that is a fundamentally different thing. But wait, damn, it gets even more mind-bending. In 1998, astronomers made a discovery that shook the foundations of cosmology. By studying distant supernovae, these exploding stars that briefly outshine entire galaxies, they discovered that the expansion of the universe is not slowing down as everyone had expected. It is speeding up. The universe is not just expanding, it is accelerating. Something is pushing space apart faster and faster with every passing moment. This mysterious something has been given a name: dark energy. And dark energy changes everything about the cosmic prison we find ourselves in. Dark energy is perhaps the most enigmatic phenomenon in all of physics. It makes up about 68% of the total energy content of the universe, yet we have almost no idea what it actually is. What we do know is what it does. Dark energy acts like a kind of anti-gravity, pushing space apart, causing the expansion to accelerate rather than decelerate. Before the discovery of dark energy, cosmologists thought that the gravitational attraction of all the matter in the universe would gradually slow down the expansion, like a ball thrown upward gradually slowing before it falls back down. But dark energy changed everything. The expansion is not slowing down, it is speeding up. And this has profound, terrifying implications for the cosmic horizon. You see, if the expansion were merely constant or slowing down, there might be hope. Given enough time, light from very distant galaxies might eventually reach us. The cosmic horizon would expand outward, revealing more and more of the universe to our view. Distant galaxies that are currently beyond our reach might eventually become reachable. The prison walls might gradually recede, giving us access to ever more of the cosmos. But with dark energy, with accelerating expansion, the opposite is true. The prison walls are closing in, not on our physical space, but on our causal reach. The sphere of the universe we can ever hope to affect or be affected by is shrinking in cosmic terms, even as the observable universe in visual terms continues to grow. This leads us to one of the most important distinctions in cosmology: the difference between the particle horizon and the event horizon. The particle horizon is the boundary of the observable universe, the maximum distance from which light could have reached us since the Big Bang. This is what most people think of when they imagine the edge of the observable universe. It is currently about 46.5 billion light-years away, and it continues to grow as more light reaches us from more distant regions. But the event horizon is something different and far more ominous. The cosmological event horizon is the boundary beyond which events occurring now can never affect us in the future. It is the point of no return for information, signals, and causality. And here is the shocking truth that most people never learn. The cosmological event horizon is much closer than the particle horizon. It is only about 16 billion light-years away. That means there are galaxies within our observable universe, galaxies we can see right now, galaxies whose light is striking our telescopes at this very moment, that we can never visit, never communicate with, never receive any future signals from. They are visible but causally disconnected. We see their past, but we can never be part of their future, nor they of ours. Let me make this more concrete with an example. Imagine a galaxy that is currently 20 billion light-years away. We can see this galaxy because its light left when it was much closer and has been traveling toward us while space expanded. We are seeing what that galaxy looked like billions of years ago, but if we sent a signal toward that galaxy right now, traveling at the speed of light, it would never arrive. The expansion of space between us and that galaxy is so rapid and accelerating so much that our signal would fall further and further behind, like a swimmer trying to reach a shore that recedes faster than they can swim. That galaxy is in our observable universe but outside our event horizon. It is a ghost we can see but never touch. Now imagine the profound implications of this. Every second that passes, more galaxies cross from inside our event horizon to outside it. More regions of space become permanently, irrevocably, eternally inaccessible to us. The cosmic prison is not static. It is actively shrinking, pulling its walls closer around us in terms of what we can ever hope to reach, and there is nothing we can do about it. No technology we could ever develop, no scientific breakthrough we could ever achieve, no amount of time or resources or determination can change this fundamental fact. The laws of physics themselves have constructed this prison, and the laws of physics offer no escape. But to truly understand why escape is impossible, we need to go deeper into the fabric of space-time itself. We need to understand light cones, causality, and why the speed of light is not just a speed limit, but the fundamental boundary of cause and effect. In physics, we visualize causality using something called a light cone. Imagine yourself at a point in space-time, right here, right now. From this point, light can travel outward in all directions. If we add time as a vertical axis and space as horizontal axes, the paths that light could take form a cone shape, expanding outward and upward into the future. This is your future light cone. Every event that lies within this cone is something you could potentially influence. You could send a signal to it, travel to it, cause something to happen there. Every event outside this cone is forever beyond your causal reach. You cannot affect it because doing so would require sending information faster than light, which is impossible. Similarly, there is a past light cone, expanding downward and outward into the past. Every event within your past light cone is something that could have influenced you, something that could have sent a signal that reached you by now. Every event outside your past light cone has had no causal effect on your present, because there has not been enough time for any influence to reach you. In a non-expanding universe, these light cones would behave simply and predictably. They would expand outward at a constant rate, encompassing more and more of space as time passes. Your causal reach would grow linearly with time, eventually including all of space if given enough time. But in our expanding universe, especially one with accelerating expansion due to dark energy, something strange and terrible happens to light cones. They get distorted, they get compressed, they get pinched off. Imagine a photon leaving a distant galaxy, heading toward us. In a non-expanding universe, this photon would simply travel through space until it reaches us. Easy. But in our expanding universe, the photon has to fight against the expansion. Space is stretching, creating more distance that the photon has to cross. If the galaxy is close enough, the photon wins the race. It crosses space faster than space can expand, and eventually it reaches us. But if the galaxy is far enough away, in a region where space is expanding faster than light, the photon loses the race. It travels toward us at the speed of light, but the space it has yet to cross is growing faster than it can traverse it. The photon will travel forever toward us and never arrive. It is condemned to eternal pursuit of a receding goal. This is why the cosmic horizon is so insidious. It is not a wall you hit. It is not a barrier you bounce off of. It is the mathematical consequence of an endless losing race. Anything beyond the horizon is traveling toward us at maximum possible speed and still falling behind. There is no way to overcome this. You cannot go faster than light. You cannot stop the expansion. You cannot close the gap. You are fundamentally, permanently, eternally separated from everything beyond that horizon. Let me offer another way to understand this. Imagine an ant walking on a rubber rope. The ant starts at one end and wants to reach the other end, which is 1 meter away. The ant walks at 1 centimeter per second. Under normal circumstances, the ant would reach the other end in 100 seconds. Easy. But now imagine that the rope is being stretched. Every second, the rope becomes twice as long. After 1 second, the rope is 2 meters long. After 2 seconds, it is 4 meters long. After 3 seconds, 8 meters long. The rope grows exponentially while the ant crawls steadily forward. Here is the beautiful mathematical truth. If the rope stretches at a constant rate, the ant will eventually reach the end, even if the rope stretches faster than the ant can walk. It will take an incredibly long time, but mathematically eventually, the ant will make it. However, if the rate of stretching itself increases over time, if the rope stretches faster and faster, then at some point, the ant will never reach the end. No matter how long it walks, no matter how determined it is, it will always be losing ground. The destination recedes faster than the ant can approach it. This is precisely our situation with the cosmic horizon. The expansion of the universe is accelerating. Dark energy is pushing space apart faster and faster with each passing moment. This means that regions of space beyond a certain distance are receding from us at an accelerating rate. Any attempt to reach them, even at the speed of light, is doomed to failure. We are the ant on an exponentially stretching rope, and we can never reach the other end. Now, let us compare this cosmic prison to another famous prison in physics, the black hole. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape once it crosses the event horizon. The event horizon of a black hole is the point of no return, the boundary beyond which escape is impossible. Is the cosmic horizon similar to a black hole's event horizon? In some ways, yes, and in some ways profoundly no. Both horizons represent boundaries beyond which information cannot escape. Both are surfaces where the fabric of space-time conspires to trap anything that crosses them. Both involve fundamental limits imposed by the nature of light, space, and time, but the mechanisms are completely different. A black hole's event horizon is created by gravitational curvature. Space is so warped by the black hole's mass that all paths, even the paths that light takes, curve back toward the singularity. No matter which direction you try to travel, you end up falling inward. The horizon is like a waterfall that pulls everything over its edge. The cosmic horizon, in contrast, is created by metric expansion. Space is not curved in any particular direction. It is simply stretching everywhere, uniformly, relentlessly. The horizon forms not because paths curve, but because paths lengthen. The distance to your destination grows faster than you can cover it. It is like trying to walk to the end of a treadmill that speeds up faster than you can run. There is another crucial difference. A black hole's event horizon is the same for all observers. It is an absolute boundary defined by the geometry of the black hole. If you and I are both watching someone fall into a black hole, we agree on where the event horizon is. But the cosmic horizon is observer-dependent. Every observer, at every location in the universe, has their own observable universe centered on themselves. The edge of my observable universe is different from the edge of your observable universe if you're standing far enough away from me. There is no absolute cosmic edge, no universal boundary that everyone agrees on. Each conscious being in the cosmos is at the center of their own private bubble of visibility and causality. And yet, despite these differences, both horizons share the same terrible finality. Once something crosses a black hole's event horizon, it can never return, never send a signal back, never influence anything outside. Once something crosses the cosmic horizon, the same is true. It is gone forever, separated from us for all eternity by the fabric of space-time itself. Now I want to take you deeper into the physics of what happens at the cosmic horizon. What actually occurs to light, to information, to objects that are carried beyond that invisible boundary? The answer involves one of the most beautiful and strange phenomena in cosmology, redshift. When a source of light moves away from you, the light it emits is stretched to longer wavelengths. Blue light becomes green, green becomes yellow, yellow becomes red. If the source is moving away fast enough, visible light shifts all the way into infrared, then into microwaves, then into radio waves. This is the Doppler effect for light, analogous to how a siren sounds lower-pitched when an ambulance drives away from you. But in cosmology, there is an additional source of redshift, the expansion of space itself. As light travels through expanding space, the space the light is traveling through stretches, and the light wave gets stretched along with it. This is called cosmological redshift, and it is distinct from Doppler redshift, though the effects look similar. For galaxies near the cosmic horizon, the cosmological redshift becomes extreme. Light that left as energetic ultraviolet or visible light arrives at us as feeble, infrared or radio waves. The light has been stretched by factors of 10, 100, 1,000 or more. And for galaxies at the very edge of the horizon, the redshift approaches infinity. The light is stretched to infinite wavelength, which means effectively zero energy, which means it becomes undetectable, indistinguishable from nothing. The galaxy fades from view, not because it stopped shining, but because its light has been stretched into oblivion. This process creates an eerie phenomenon for galaxies that are being carried across the cosmic horizon by expansion. From our perspective, they appear to slow down as they approach the horizon, their light becoming more and more redshifted, their apparent time dilation becoming more and more extreme. They seem to freeze at the horizon, their final light stretched and reddened until it fades below detectability. They become cosmic ghosts, frozen in time at the edge of our visible universe, slowly fading to invisibility over eons, and once they disappear, they are gone forever. No trace of their existence will ever reach us again. This is remarkably similar to what happens to objects falling into black holes. From an outside observer's perspective, something falling into a black hole appears to slow down as it approaches the event horizon, its light becoming more and more redshifted, until it seems to freeze at the horizon, fading to invisibility. The mathematics is different, but the observable effect is strangely parallel. In both cases, the horizon acts as a one-way membrane that traps objects and information, causing them to fade from view like ghosts dissolving into mist. But here is something even more profound to consider. From the perspective of the object falling into a black hole, nothing special happens at the event horizon. There is no wall, no barrier, no sensation of crossing a boundary. The falling object simply continues falling, unaware that it has crossed a point of no return. It is only later, when escape becomes manifestly impossible, that the reality of the situation becomes clear. And similarly, for a hypothetical observer in a distant galaxy being carried beyond our cosmic horizon by expansion, nothing special would happen at the moment of crossing. They would not feel any barrier or experience any transition. They would simply continue existing, unaware that they have become forever separated from us. The horizon is invisible, intangible, and yet utterly absolute. This raises deep questions about the nature of reality and observation. If the cosmic horizon is different for every observer, if every conscious being has their own private bubble of visibility and causality, then what is the true nature of the universe? Is there an objective reality beyond what any observer can see? Or is reality somehow observer-dependent, existing only insofar as it can be observed? These are questions that physicists and philosophers continue to debate, and the cosmic horizon forces us to confront them in the starkest possible terms. Let us now consider the mathematics of impossibility more carefully. I want to prove to you, as rigorously as I can in ordinary language, that escape from the observable universe's horizon is truly impossible. Not just difficult, not just impractical, but fundamentally, mathematically, absolutely impossible. Consider the following argument. The speed of light is the maximum speed at which any signal, any information, any causal influence can propagate. This is not just an engineering limitation or a technological constraint. It is a fundamental feature of space-time woven into the fabric of reality by the equations of special relativity. Exceeding the speed of light is not like breaking the sound barrier, which was once thought impossible, but turned out to be merely difficult. Exceeding the speed of light would require infinite energy, and even then it would not work. The speed of light is not a barrier that sufficiently advanced technology could overcome. It is the definition of how fast causality can propagate. Now consider the cosmic horizon. Beyond this boundary, space is receding from us faster than the speed of light due to expansion. Any signal we send toward these regions, traveling at maximum possible speed, will lose ground to the expansion. The gap between us and the horizon grows faster than we can close it. Therefore, reaching the horizon or anything beyond it is impossible. But wait, you might object. What about special tricks, loopholes, exotic physics? What about warp drives and wormholes and quantum entanglement? Surely sufficiently advanced technology could find a way around this cosmic speed limit. Let us examine these possibilities one by one. First, warp drives. In 1994, physicist Miguel Alcubierre proposed a theoretical mechanism for faster-than-light travel that does not violate special relativity. The idea is to contract space in front of your ship and expand space behind it, creating a bubble of flat space that carries you along at arbitrarily high speeds. You're not moving through space faster than light. Space itself is carrying you, just as the expansion of the universe carries galaxies faster than light. This seems promising at first. If the universe can expand faster than light, why can we not harness the same mechanism for transportation? The problems with warp drives are many and severe. First, creating a warp bubble would require exotic matter with negative energy density, something that probably does not exist and may be impossible. Second, even if we could create a warp bubble, we could not control it from inside. Any signal we send to the walls of the bubble would travel at the speed of light, but the walls would be moving faster than light relative to us, so our signals could never reach them. We would be passengers, not pilots. Third, and most crucially for our purposes, a warp drive cannot take you to a destination outside your future light cone. You cannot use a warp drive to reach somewhere that light cannot reach. The warp bubble must be set up in advance along your entire route, which requires the destination to be causally accessible. For destinations beyond the cosmic horizon, this is impossible. The warp drive, if it could exist at all, cannot escape the cosmic prison. Second, wormholes. These are hypothetical tunnels through space-time, connecting distant points through higher dimensions, offering shortcuts that bypass the normal limitations of travel through space. If a wormhole connected our region of space to a region beyond the cosmic horizon, could we use it to escape? The problems here are also severe. Wormholes that would allow travel, traversable wormholes, would require exotic matter to hold them open, the same impossible negative energy we needed for warp drives. More fundamentally, even if traversable wormholes could exist, they would be subject to causality constraints. You cannot use a wormhole to violate causality, to send signals backward in time, or to reach events outside your light cone. The mathematics of general relativity that allows wormholes to exist also constrains how they can be used. They cannot serve as escape routes from the cosmic prison. Third, quantum entanglement. Einstein called this spooky action at a distance. When two particles are entangled, measuring one instantly affects the other, no matter how far apart they are. This seems like faster-than-light communication, a way to send signals across any distance instantaneously. But it is not. This is one of the most common misconceptions about quantum mechanics. Entanglement creates correlations between particles, but it cannot be used to transmit information. The outcomes of measurements on entangled particles are random, and you cannot control what outcome your partner will measure. You can verify after the fact that your measurements were correlated, but this verification requires classical communication, which travels at the speed of light. The no communication theorem proves mathematically that entanglement cannot be used to send information faster than light. Quantum mechanics, despite its weirdness, respects the cosmic speed limit. Fourth, tachyons. These are hypothetical particles that always travel faster than light. If they existed, they could potentially carry signals beyond the cosmic horizon. But tachyons almost certainly do not exist, and if they did, they would create paradoxes. A signal traveling faster than light could, from some reference frames, arrive before it was sent. This would allow messages to be sent backward in time, creating causal paradoxes where effects precede causes. The universe seems to forbid this, and the absence of observed tachyons, combined with the paradoxes they would create, strongly suggests they are impossible. I could continue examining other speculative ideas, other hypothetical physics, other imagined loopholes. But the pattern would be the same. Every idea that seems at first like it might offer escape either violates known physics, requires impossible resources, or turns out not to actually reach beyond the horizon when analyzed carefully. The prison is airtight. The laws of physics that create the horizon also forbid any mechanism for escaping it. Let me make the impossibility even more visceral with a thought experiment. Imagine that you are an immortal being with infinite resources. You have access to every possible technology that the laws of physics allow. You decide to embark on a journey to escape the observable universe. You build the most advanced ship imaginable and launch toward the cosmic horizon at the speed of light. What happens? At first, you make great progress. Stars and galaxies whiz past as you hurtle through space. But gradually you notice something disturbing. The edge of the observable universe does not seem to be getting closer. In fact, it seems to be getting farther away. The expansion of space is accelerating, and with each passing moment the horizon recedes faster. You push your ship harder, squeezing every last bit of speed out of it, but it is already travelling at the maximum possible speed. There is nothing more you can do. The horizon continues to recede. Millennia pass, eons pass. You travel for billions of years at the speed of light, and the horizon is no closer than when you started. In fact, it is farther away. The prison walls have expanded faster than you could approach them. You try a different strategy. Instead of heading directly for the horizon, you try to catch up to a specific galaxy that is near the edge. You watch this galaxy through your telescope as you approach. But as you travel, you see the galaxy slowly reddening, its light shifting to longer wavelengths. The galaxy seems to be slowing down relative to the horizon, freezing at the edge, fading to invisibility. By the time you reach where the galaxy was, it is gone, carried beyond the horizon by expansion, lost to you forever. You're alone in an empty region of space that is itself being carried toward the horizon you can never reach. This is the true nature of the cosmic prison. It is not just that you cannot escape, it is that the prison actively defeats your every attempt. The harder you try to reach the edge, the faster the edge recedes. The longer you travel, the more isolated you become. Escape is not merely impossible, it becomes more impossible with every passing moment. Now let us shift our perspective and consider what this cosmic prison means for humanity and for any intelligent life that might exist in the universe. The implications are profound and, depending on your philosophical perspective, either terrifying or strangely beautiful. First, consider interstellar travel. Even within our own galaxy, the distances are immense. The nearest star to our Sun, Proxima Centauri, is about 4 light-years away. At the speed of light, it would take 4 years to get there. At the speeds our fastest spacecraft have achieved, it would take tens of thousands of years. But at least it is reachable in principle. With enough time and technology, we could potentially visit every star in the Milky Way. Interstellar travel is difficult, but not impossible. Intergalactic travel is another matter. The nearest large galaxy to our own, Andromeda, is about 2.5 million light-years away. This is vastly farther than any star in our galaxy. But here is the surprising good news. Andromeda is actually approaching us, not receding. The gravitational attraction between the Milky Way and Andromeda is stronger than the expansion of space between us, so the two galaxies are falling toward each other. In about 4 billion years, they will collide and merge into a single giant galaxy, sometimes called Milkdromeda. So Andromeda, at least, will become very accessible indeed. But beyond our local group of galaxies, which includes the Milky Way, Andromeda, and a few dozen smaller companions, the situation is dire. All other galaxies are receding from us, carried away by the expansion of space. And because of dark energy, this recession is accelerating. Galaxies that are currently within our observable universe are crossing the cosmic horizon, becoming forever unreachable. Given enough time, all galaxies beyond our local group will be beyond the horizon. We will be marooned on an island of a few merged galaxies in an otherwise empty universe. This brings us to one of the most haunting implications of the cosmic horizon, the future of knowledge itself. Right now, we can look out at the universe and see billions of galaxies. We can detect the cosmic microwave background radiation, the afterglow of the Big Bang, and use it to understand the early universe. We can measure the expansion rate and infer the existence of dark energy. We have access to a wealth of cosmological information that tells us the history and nature of the cosmos. But in the far future, perhaps 100 billion years from now, all of that information will be gone. Every galaxy beyond the local group will have crossed the cosmic horizon and faded from view. The cosmic microwave background will be redshifted to undetectable wavelengths. All evidence of the Big Bang, of the expansion, of the billions of galaxies that once filled the sky, will have vanished. A civilization arising in that far future, knowing only their single merged galaxy in an otherwise black and empty universe. It would have no way to know the truth. They would look out at the void and reasonably conclude that their galaxy is all there is, an island universe in an infinite sea of nothingness. They would not know about the Big Bang. They would not know about expansion. They would not know that the universe was once filled with countless galaxies, all visible and measurable. The truth would be hidden from them forever, erased by the cosmic horizon. This is a kind of cosmic censorship, not a conspiracy but a consequence of physics. The universe is actively hiding its own history, erasing the evidence of its true nature, ensuring that future generations can never know what we know today. We are privileged to exist at a time when the cosmos still reveals itself to us. Future beings may not be so lucky. Let me pause here and reflect on the philosophical weight of what we have discovered. We have found that the universe contains a fundamental boundary, a horizon beyond which nothing can escape, nothing can be known, nothing can be affected. We have found that this boundary is not a physical wall but a mathematical consequence of expansion, acceleration, and the speed of light. We have found that the boundary is closing in, that our causal reach is shrinking, that more and more of the cosmos is becoming forever inaccessible, and we have found that future civilizations will be denied even the knowledge that this is happening, cut off from the truth by the very expansion that imprisons them. What does this mean for the meaning of existence? What does it mean for our place in the cosmos? What does it mean for the dreams of exploration, expansion, and connection that have driven humanity since we first looked up at the stars? One perspective is despair. The cosmic horizon seems to render our aspirations meaningless. No matter how advanced we become, no matter how far our technology evolves, we can never escape our cosmic bubble. We can never explore more than a tiny fraction of what exists. We can never meet whatever civilizations might exist beyond the horizon, never exchange ideas with them, never know their stories. We are alone in our prison, and the prison is shrinking. But there is another perspective, one that finds beauty and meaning in our limitations. Consider this. The cosmic horizon defines what we can affect and be affected by. Everything within the horizon is, at least in principle, part of our causal universe. We can potentially reach it, communicate with it, influence it. Beyond the horizon is not nothingness, but simply otherness, existence that is separate from ours, independent, following its own course. The horizon does not diminish what is inside it. It simply defines the boundaries of our realm. And consider this. We exist at a unique moment in cosmic history. We are early enough that the cosmos still reveals itself to us, that we can see the evidence of the Big Bang, measure the expansion, count the billions of galaxies. Future beings will not have this privilege. They will inherit a smaller, darker, more limited view of reality. We are custodians of knowledge that will someday be lost, witnesses to a universe that will someday be hidden. This gives our existence a kind of cosmic significance, a responsibility to understand and record what we can while the universe still permits it. And consider this. The scale of what lies within our reach is still beyond comprehension. Our observable universe contains roughly 2 trillion galaxies, each containing hundreds of billions of stars, each potentially hosting planets, moons, and possibilities we cannot imagine. Even if we can never reach beyond the horizon, the universe within the horizon offers more wonders than any civilization could ever fully explore. The prison may have walls, but it is a very large prison indeed. I want to spend some time now exploring the deeper physics of the cosmic horizon, the connections to black holes and quantum mechanics that hint at even stranger truths lurking beneath the surface of our understanding. We have already noted the similarity between cosmic horizons and black hole event horizons. Both are surfaces beyond which information cannot escape. Both cause objects and light approaching them to redshift and fade to invisibility. Both represent fundamental boundaries on causality and knowledge. But the parallels go even deeper into the quantum realm. In 1974, Stephen Hawking made a remarkable discovery. He showed that black holes are not perfectly black. They emit radiation, now called Hawking radiation, due to quantum effects near the event horizon. In the vacuum of space, quantum fluctuations constantly create pairs of particles and antiparticles. These pairs normally annihilate almost instantly, returning their borrowed energy to the vacuum. But near a black hole's event horizon, something special happens. One particle of the pair can fall into the black hole while the other escapes. The escaping particle carries away energy, which must come from somewhere. It comes from the black hole itself, causing the black hole to slowly lose mass and eventually evaporate over astronomical timescales. Here is the profound implication. The cosmic horizon also emits radiation, for essentially the same reason. This radiation, sometimes called Gibbons-Hawking radiation or de Sitter radiation, is incredibly feeble, with a temperature far below anything we could detect. But it exists. the accelerating expansion of the universe creates an effective horizon around every observer, and this horizon glows with quantum radiation, just like a black hole. The universe itself is luminous with the faint glow of its own expansion. This connects to another deep principle in physics, the holographic principle. This principle, arising from studies of black holes and string theory, suggests that all the information contained within a volume of space can be encoded on the boundary of that space, like a hologram that encodes a three-dimensional image on a two-dimensional surface. If the holographic principle applies to the cosmic horizon, then all the information about the observable universe might be encoded on the horizon itself. The interior of our cosmic bubble would be a projection from the boundary, and the boundary would contain the complete description of everything within. This is highly speculative, and physicists are far from consensus on whether the holographic principle applies to cosmological horizons. But if it does, the horizon takes on even greater significance. It would not just be a boundary on what we can observe, it would be the fundamental encoding of our reality, the screen on which the movie of our universe is projected. There are other deep connections between the cosmic horizon and the nature of reality. Consider the concept of horizon complementarity, developed in the context of black holes by Leonard Susskind and others. This principle suggests that different observers can have radically different but equally valid descriptions of reality near a horizon. An observer falling into a black hole would have one experience, passing through the horizon without incident and continuing toward the singularity. An observer watching from outside would have a different experience, seeing the falling observer slow down, redshift, and fade at the horizon, never quite crossing it. Both descriptions are correct from their respective perspectives, even though they seem incompatible. A similar complementarity might apply to the cosmic horizon. We, inside our observable universe, have one description of reality. A hypothetical observer beyond the horizon would have a different description, one that does not include us at all. Both descriptions would be complete and consistent from their respective perspectives. There is no objective, God's-eye view that encompasses both. Reality itself might be observer-dependent at the most fundamental level. These ideas are at the frontier of physics, where quantum mechanics, general relativity, and cosmology intersect. We do not yet have a complete theory that unifies these domains. A theory of quantum gravity that would tell us the ultimate nature of horizons. But the questions the cosmic horizon raises are pushing us towards such a theory. The universe is challenging us to understand it more deeply, and the horizon is one of the greatest puzzles it has posed. Let me now address some common misconceptions about the cosmic horizon, misunderstandings that even scientifically literate people often have. Misconception. Number 1. If nothing can escape the cosmic horizon, why can we see beyond it? This conflates two different things, seeing and reaching. We can see galaxies near the edge of the observable universe because their light has had time to reach us, even though the galaxies themselves are now far beyond where they were when the light left them. We are seeing the past, not the present. We cannot visit these galaxies, cannot send them messages, cannot interact with them in any way. They are visible ghosts, images from the past of objects that are now forever beyond our reach. Seeing is not the same as reaching. The cosmic horizon allows us to see some things we can never touch. Misconception number 2. Could we not just wait for expansion to slow down and the horizon to become reachable? This might be true if dark energy did not exist, or if dark energy weakened over time. But all evidence suggests that dark energy is constant or even increasing. The expansion is accelerating, not decelerating. Waiting will not help. In fact, waiting makes things worse. The longer we wait, the more galaxies cross the horizon and become unreachable, the more the universe contracts in terms of what we can influence. Time is not our friend in this race. Time is on the side of the horizon. Misconception number 3. The cosmic horizon is the edge of the universe, the boundary beyond which there is nothing. This confuses the observable universe with the entire universe. The cosmic horizon is our boundary, not the universe's. Beyond the horizon, more universe almost certainly exists, perhaps infinitely more, containing countless galaxies and wonders we can never see. The horizon is a limit on our knowledge and reach, not a limit on existence itself. The universe does not end at the horizon. Only our access to it does. Misconception number 4. If space can expand faster than light, does that violate Einstein's theories? Number Special relativity says that nothing can travel through space faster than light, but it places no limits on the expansion of space itself. Space can expand at any rate. Objects carried along by this expansion can be separated at any speed, including speeds greater than light. This does not violate relativity because the objects are not moving through space faster than light. They are stationary relative to the space around them, but the space itself is growing. It is a subtle distinction, but a crucial one. Misconception. Number 5. If space is expanding, is everything expanding, including atoms, planets, and people? No. Expansion only dominates where gravity and other forces are weak. Within galaxies, within solar systems, within objects, gravity and electromagnetic forces hold things together against the expansion. The space between atoms in your body is not expanding because the forces between those atoms are far stronger than the expansion. Only on the larger scales, in the vast voids between galaxy clusters, does expansion overcome local binding forces and carry things apart. Misconception number 6. Is the cosmic horizon the same as the edge of what we could see if we had better telescopes? Not quite. There is a fundamental limit to what light can show us, which is the particle horizon at about 46 billion light-years. But better telescopes could in principle show us everything within the particle horizon up to that limit. The event horizon, at about 16 billion light-years, is different. It is the boundary beyond which events happening now can never affect us. Galaxies between the event horizon and the particle horizon are visible but unreachable. Galaxies beyond the particle horizon are invisible and unreachable. Better telescopes cannot change these boundaries because the boundaries are set by the fundamental structure of space-time, not by the sensitivity of our instruments. Having addressed these misconceptions, let me now paint a picture of the far future, a timeline of cosmic isolation that stretches to the end of time itself. We begin now in the present day, roughly 13.8 billion years after the Big Bang. We can see approximately 2 trillion galaxies scattered across the observable universe. The cosmic microwave background fills the sky, a faint echo of the primordial fireball containing detailed information about the early universe. The expansion of space is accelerating, driven by dark energy, but many galaxies are still within our event horizon, still theoretically reachable, still part of our causal future. Fast forward 100 billion years. The Milky Way has long since merged with Andromeda and several smaller galaxies to form a giant elliptical galaxy, sometimes called Milkdromeda. All other galaxies have receded beyond the cosmic horizon. The sky beyond Milkdromeda is utterly black. There are no other galaxies visible, no matter how powerful the telescopes. The cosmic microwave background has been redshifted to undetectable wavelengths. A civilization arising now would see only their single galaxy in an infinite void and would have no way to know that billions of other galaxies ever existed. Fast forward 1 trillion years, the star formation era is ending. Most of the gas in Milkdromeda has been used up, locked away in stellar remnants. New stars are increasingly rare. The galaxy is populated primarily by red dwarfs, the longest-lived stars, slowly burning through their hydrogen over trillions of years. The universe is darker than before, the void even more empty. Fast forward 100 trillion years. The last stars are dying, even the longest-lived red dwarfs have exhausted their fuel. The galaxy is now a collection of stellar corpses, white dwarfs, neutron stars, black holes. There is no starlight, only the fading glow of cooling remnants. Any intelligent being still existing must survive on whatever energy they can scavenge, perhaps from the slow decay of matter or the evaporation of black holes. Fast forward 10 to the power of 40 years, an unimaginably vast span of time. If protons decay, as some theories predict, then even the stellar remnants are dissolving. Matter itself is unstable on these timescales. White dwarfs and neutron stars evaporate into radiation. Only black holes remain, eternal holes of darkness in a sea of radiation and elementary particles. Fast forward 10 to the power of 100 years, a number so large it has no name in everyday language. The last black holes are evaporating. Hawking radiation slowly bleeds them of mass and energy. When the last black hole evaporates, all organized structure in the universe will be gone. There will be only a thin soup of particles and radiation, spread across a space so vast that particles rarely encounter each other. This is the heat death of the universe, the state of maximum entropy. the final equilibrium from which no further change is possible. Throughout all this time, the cosmic horizon remains. In fact, it becomes more dominant. As the universe expands and cools, the observable universe becomes ever more isolated, ever more cut off from whatever might lie beyond. If other bubbles of structure exist beyond the horizon, they are forever separate from us, evolving toward their own heat deaths in parallel isolation. Is this depressing? Perhaps. It is certainly humbling. The universe that seemed so vast and full of possibility is revealed to be a finite bubble, shrinking in significance, heading toward a cold and empty end. Our cosmic prison is not just inescapable. It is also running down, its energy dissipating, its structures dissolving, its information fading into the noise. But let me offer a different perspective, one that finds meaning and even beauty in this cosmic picture. First, the timescales involved are beyond comprehension. The current age of the universe, 13.8 billion years, is nothing compared to the trillions of years during which stars will continue to shine, the unimaginable eons during which intelligence could potentially persist. We are at the very beginning of the story, not the end. The universe has barely started its long evolution. What might happen in the vast stretches of time ahead is beyond our ability to predict or imagine. Second, the scale of what lies within our reach is still breathtaking. Our observable universe contains more galaxies than there are grains of sand on all the beaches of Earth. Each galaxy contains more stars than we could count in a lifetime. The diversity of worlds, the possibilities for life and intelligence, the wonders waiting to be discovered within our cosmic bubble are effectively infinite from a human perspective. We will never run out of things to explore within the horizon, even if we cannot explore beyond it. Third, our existence at this moment in cosmic history is remarkably fortunate. We live at a time when the universe still reveals itself to us, when we can see the evidence of the Big Bang, measure the expansion, count the galaxies, and understand our place in the cosmos. Future civilizations will not have this privilege. They will be denied the knowledge we have gained. We are the witnesses, the archivists, the consciousness that can comprehend the universe while comprehension is still possible. This gives our existence a kind of cosmic significance that transcends our physical limitations. Fourth, the cosmic horizon teaches us something profound about the nature of knowledge and existence. There are limits to what can be known, boundaries beyond which no investigation can penetrate. This is not a failure of science or technology, it is a fundamental feature of reality. Accepting this, making peace with it, finding meaning within our boundaries rather than raging against them, is a kind of cosmic wisdom. The universe is not obligated to be fully knowable. That it reveals as much as it does is a gift. Now let me bring our journey toward a conclusion by synthesizing everything we have learned into a coherent picture. The cosmic horizon exists because of three fundamental facts about our universe. First, the speed of light is the maximum speed at which information, causality, and influence can propagate. This is not a technological limitation, but a fundamental feature of space-time. Second, space is expanding, carrying everything in the universe apart from everything else. This expansion has been ongoing since the Big Bang and continues today. Third, the expansion is accelerating due to dark energy. This means that objects beyond a certain distance are receding from us faster than light and will recede even faster in the future. Together, these three facts create an inescapable prison. Anything beyond the cosmic horizon is receding faster than the speed of light. Any attempt to reach it, even at maximum possible speed, will fail because the distance grows faster than we can cross it. The acceleration ensures that this situation becomes more severe over time, not less. There is no waiting it out, no technology that could overcome it, no loophole in the laws of physics that would allow escape. The cosmic horizon is different from a black hole's event horizon in mechanism, but similar in effect. Both trap information and objects beyond a certain boundary. Both cause approaching objects to redshift and fade from view. Both represent fundamental limits on causality and knowledge. The implications for humanity and any intelligent life are profound. We will never explore the universe beyond our local group of galaxies. We will never contact whatever civilizations might exist beyond the horizon. The universe will gradually hide its own history from future observers, erasing the evidence of the Big Bang and the billions of galaxies that once filled the sky. But the horizon also gives our existence meaning. We are the consciousness that can know the truth while the truth is still knowable. We are the witnesses to a cosmos that will someday be hidden. We have access to wonders and knowledge that future beings will never possess. This is both a privilege and a responsibility. And so, as we conclude our journey, let me leave you with some final thoughts to carry with you. The next time you look up at the night sky, know that you are looking at a prison wall, but also know that it is the most beautiful prison imaginable, filled with more wonders than you could explore in 1 billion lifetimes. The stars you see are your fellow inmates, and together you share a bubble of reality that is vast beyond comprehension, even if it is bounded by the cosmic horizon. Know that the light reaching your eyes has traveled for millions or billions of years, crossing the expanding void to bring you a message from the past. That light is a gift from the universe, a glimpse of realities that are now forever beyond your reach. Treasure it, study it. Let it fill you with wonder. Know that somewhere beyond the horizon, beyond the boundary of what you can ever see or know, more universe almost certainly exists. Other galaxies, other stars, perhaps other minds gazing up at their own skies and wondering about their own horizons. You can never meet them, never communicate with them, never know their stories. But knowing that they might exist, that the universe is vaster than your vision, can fill you with a strange and beautiful humility. Know that the horizon is not a condemnation but a definition. It tells you what your universe is, what you can potentially affect, what is part of your reality. Everything within the horizon is, in principle, accessible to you. The boundary is not a denial of possibility but a specification of domain. Your domain is immense, filled with opportunity, and it is yours. Know that you exist at a special time. The cosmos will not always reveal itself as it does now. The evidence of the Big Bang, the billions of visible galaxies, the accelerating expansion, all of this will someday be hidden from view. You are a witness to a universe that is showing you its secrets before it falls silent. Do not waste this moment. Look, learn, understand, and remember. Soul? The cosmic horizon is the ultimate boundary, the final wall, the prison from which nothing can escape. It is made not of matter but of mathematics, not of force but of the fundamental structure of space-time. It has trapped you since the moment of your birth and will hold you until the end of time. And yet within this prison you can ponder the cosmos. You can understand why you are trapped. You can appreciate the vastness that surrounds you. You can create meaning, seek knowledge, and marvel at the beauty of existence. The prison walls cannot prevent you from thinking, feeling, wondering, and being filled with awe. In the end, perhaps that is the deepest truth the cosmic horizon teaches us. We are finite beings in an infinite cosmos, bounded creatures in an unbounded universe. We cannot escape our limitations, but we can transcend them through understanding. We cannot touch the stars beyond the horizon, but we can know they are there. We cannot live forever, but we can comprehend eternity. The observable universe's horizon is why nothing can escape. But it is also why everything within matters so profoundly. Your life, your thoughts, your connections with others, your moments of joy and sorrow, all of these unfold within a cosmic bubble that is uniquely yours. The horizon defines your world, and within that world you are free. Look up at the stars tonight. They are calling to you from across the void, their ancient light a message from the past, their present existence forever hidden. They are beautiful, they are mysterious, they are unreachable, and they are yours. This is the observable universe's horizon. This is why nothing can escape. This is the magnificent prison in which we live, the cosmic boundary that shapes our reality, the final wall beyond which no journey can ever venture. I hope this exploration has changed how you see the universe, how you understand your place in it, how you feel about the vast and strange reality we all share. If it has, take a moment to subscribe to this channel and join me for more journeys to the edges of existence. Leave a comment below telling me which aspect of the cosmic horizon you find most fascinating, most terrifying, or most beautiful. Share this video with someone who loves to ponder the deep mysteries of the cosmos. Together, we can appreciate the universe while it still allows itself to be appreciated. The horizon is waiting, the cosmos is watching, and somewhere, in the unimaginable expanses beyond what we can ever see, the universe continues, vast and silent and full of secrets we will never know. Thank you for joining me on this journey. Until next time, keep looking up, keep wondering, and never stop asking why. And remember, the universe gave you eyes to see the stars, a mind to understand the horizon, and a heart to feel the wonder of existence. Use these gifts well. They are the only escape that matters, the only transcendence within reach, the only freedom that the cosmic prison permits. The stars are calling, the horizon is watching, and you, small and finite and mortal as you are, have understood something that the stars themselves cannot know. Why the prison exists and why escape is impossible, and why that impossibility is in its own strange way beautiful. That understanding is your gift to the cosmos. Carry it with you, and let it shape how you live. And when you look up at the night sky, let the cosmic horizon remind you of what matters. This moment, this place, this life, this precious bubble of reality that is all you will ever have and all you will ever need. The observable universe's horizon is the boundary of everything you can know. But within that boundary, knowledge is infinite. The horizon is the edge of everywhere you can go. But within that edge, the journey never ends. The horizon is the limit of everyone you can reach. But within that limit, connection is still possible, still meaningful, still beautiful. Nothing can escape the observable universe's horizon. But within that horizon, everything awaits. This is the truth. This is the wonder. This is the cosmic mystery that has shaped our exploration today. Now I want to take you even deeper, beyond the physics and into the philosophy, beyond the mathematics and into the meaning. What does it truly mean to be bounded by a cosmic horizon? How should this knowledge change how we live, how we think, how we feel about our place in existence? Some might argue that the cosmic horizon renders life meaningless. If we are trapped in a shrinking bubble, if the universe will eventually hide itself from all observers, if everything we know and love will eventually fade into the cold emptiness of heat death, then what is the point? Why strive? Why create? Why love? Why wonder? The end is written in the equations of cosmology, and that end is darkness, isolation, and oblivion. But I want to offer a different perspective, one that I believe is more true to the reality we have discovered. The cosmic horizon does not render life meaningless. It renders life precious. Consider, if the universe were fully accessible, if we could explore forever without limit, if there were no boundaries on what we could know or where we could go, would that make existence more meaningful? Or would it, paradoxically, make it less so? Without limits, without scarcity, without finitude, what would drive us to treasure what we have, to cherish this moment, to appreciate the fleeting beauty that surrounds us? The horizon teaches us that time matters. We exist at a special moment when the universe reveals itself. Future generations will not have this privilege. The knowledge we gain now, the observations we make, the understanding we achieve, all of this will someday be lost to the cosmic censorship of expansion. We are the archivists of a truth that will eventually be forgotten. This gives our work a significance that transcends our individual lives. We are not just learning for ourselves, we are learning for all the future minds that will never have the chance. The horizon teaches us that connection matters. Every galaxy beyond our local group is being carried away by expansion. Every distant civilization, if any exist, is becoming more isolated with each passing moment. The bonds we can form, the communications we can establish, the relationships we can build, all of these are limited by the cosmic horizon. This makes the connections we do have more valuable. The beings we can reach, the minds we can touch, the hearts we can move, these are our cosmic family, the co-inhabitants of our bounded universe. Cherish them. The horizon teaches us that wonder matters. The universe did not have to be comprehensible. It did not have to reveal its secrets to curious minds. It did not have to contain patterns that can be discovered, laws that can be understood, beauties that can be appreciated, but it does. Within our cosmic bubble, the universe offers itself to investigation. It answers our questions, sometimes in ways we expected, and sometimes in ways that shatter our assumptions. This ongoing dialogue between mind and cosmos is one of the most precious aspects of existence. The horizon places limits on it, yes, but within those limits the dialogue continues. As long as we ask questions, the universe will have answers. Not all answers, but enough, more than enough. Let me tell you what I see, when I look up at the night sky, knowing what I now know about the cosmic horizon, I see a vast dome of ancient light, like photons that have been travelling for millions or billions of years to reach my eyes. Each point of light is a message from the past, a snapshot of a star or galaxy as it was eons ago. The present state of these objects is unknowable. Only their history reaches me. I am surrounded by ghosts, by memories, by echoes of events that occurred before humans existed, before Earth formed, before the sun ignited. The past is all around me, preserved in light. I see boundaries within boundaries within boundaries. The nearest stars are a few light years away, reachable in principle if our technology advances sufficiently. The Milky Way stretches 100,000 light years across, vast but not infinite, explorable over cosmic timescales. The local group of galaxies extends a few million light years, gravitationally bound and eventually merging into a single conglomerate. Beyond that, the observable universe stretches tens of billions of light years, visible but not reachable, known but not touchable. And beyond that, the event horizon, beyond which nothing happening now can ever affect us. And beyond that, the unknown, the possibly infinite expanse of universe that we can never access, never observe, never even confirm exists. Each boundary encompasses more than I could ever explore, and all of them together define the nested structure of my cosmic prison. I see time flowing in multiple directions at once. The light from distant galaxies shows me their past. The expansion of space carries them into a future I can never witness. My own present is a thin slice of time, the knife edge where past and future meet, the only moment in which I can act. The horizon is not just a boundary in space, it is a boundary in time, the edge of my causal future, the limit of what my actions can ever influence. I see beauty that needs no justification, the spiral arms of distant galaxies, the colourful nebulae where stars are born, the cosmic web of filaments connecting galaxy clusters across billions of light years. None of this exists for a purpose. None of it was made for human appreciation. It simply is, a byproduct of physical laws playing out over cosmic time. And yet, to a mind that can perceive it, it is beautiful beyond words. The universe did not have to be beautiful, but it is, and we are here to witness it. I see my own insignificance and my own importance, simultaneously and without contradiction. I am a collection of atoms, organized briefly into a pattern that can think and feel and wonder, soon to dissolve back into the cosmic soup from which I arose. Compared to the universe, I am nothing, a mote, a flicker, a statistical fluctuation in the endless dance of matter and energy. And yet I am a part of the universe that has become aware of itself. Through me, through beings like me, the cosmos contemplates its own existence. The universe has developed eyes to see itself, minds to understand itself, hearts to love itself. This is remarkable. This is precious. This is significant, regardless of the scales of space and time that dwarf my individual existence. And I see the horizon, the gentle curve beyond which the universe hides itself. Not a wall, not a barrier, just the mathematical limit of causality in an expanding cosmos. It is always there, certain always at the same distance in a sense, always receding as I chase it, always defining the boundary between what I can know and what I cannot. The horizon is patient, it is eternal. It will be there when the last star dies, when the last black hole evaporates, when the last thought flickers out in the cold darkness of heat death. The horizon is the final constant in a universe of change. And I think, this is enough. This is more than enough. Within the horizon, there is more wonder than I could exhaust in 1 trillion lifetimes. The boundary does not diminish what lies within it. The prison does not make the inmates less alive, less curious, less capable of joy. We are bounded, yes. We are finite, yes. We will eventually end, yes. But here now in this moment we exist. We wonder. We understand. And that is a miracle that no horizon can contain. Let me share with you a vision of what humanity might achieve within the cosmic horizon, a dream of the future that acknowledges our limits while embracing our potential. In the near future, perhaps within the next few centuries, we will become a multiplanetary species. Mars, the moons of Jupiter and Saturn, perhaps even the clouds of Venus or the icy surfaces of Kuiper Belt objects, will host human settlements. We will transform ourselves from a species confined to a single world into a species spread across our solar system. This will not escape the cosmic horizon, but it will be a start, a proof of concept, a demonstration that humanity can expand beyond its birthplace. In the more distant future, perhaps within the next few millennia or tens of millennia, we will send probes and perhaps even settlers to nearby stars. Proxima Centauri, Alpha Centauri, Barnard's Star, Tau Ceti, the neighborhood of stars within a few dozen light years will become known territories, their planets explored, their resources catalogued, their mysteries revealed. The interstellar expansion of humanity will be slow by cosmic standards, but swift by human standards, spreading our presence across a growing sphere of the galaxy. In the far future, perhaps over the next few million years, we will become a galactic civilization. Every star in the Milky Way will be within our reach, every planet a potential home, every moon a potential resource. We will encounter other intelligent species perhaps, or find ourselves alone in our galaxy. Either way, we will have transcended the limitations of a single world, a single star, a single local region of space. We will be a galaxy-spanning civilization, and the wonders we will create and discover defy imagination. And then we will encounter the wall, the edge of the local group, the boundary beyond which gravitational binding fails and expansion carries galaxies away faster than we can follow. Andromeda will merge with the Milky Way, and a few smaller satellite galaxies will be swept up in the fusion. But everything else, the billions of galaxies beyond the local group, will be beyond our reach, carried over the cosmic horizon by the relentless expansion of space. We will have conquered the galaxy, but the universe will remain forever beyond our grasp. What then? What does a civilization do when it has reached the final wall? Perhaps we will turn inward, exploring the infinite complexity of what we have rather than reaching for what we can never attain. The local group contains hundreds of billions of stars, countless planets, unimaginable diversity. Even a civilization lasting billions of years could not exhaust the possibilities within this single merged mega-galaxy. We will create, we will discover, we will evolve, we will transform ourselves in ways we cannot currently imagine. The horizon will limit our external expansion, but not our internal growth. Perhaps we will turn toward the deepest questions, the mysteries that no telescope or experiment can directly resolve. Why is there something rather than nothing? Why does the universe obey mathematical laws? Why does consciousness exist? What is the ultimate nature of reality? These questions might not have answers, but the pursuit of them might be its own reward, an eternal quest that gives meaning to existence, even when external exploration has reached its limit. Perhaps we will make peace with our finitude, accepting the cosmic horizon as a fundamental aspect of reality rather than an obstacle to be overcome. Just as individuals must accept their own mortality, finding meaning in life even though it ends, civilizations must accept their cosmic mortality, finding meaning in their existence even though it is bounded. This acceptance is not defeat, it is wisdom. It is the recognition that limits are not the enemy of meaning but the source of it. Perhaps we will discover something unexpected, some loophole in the laws of physics that we cannot currently anticipate. Throughout history, the universe has surprised us with phenomena we did not predict: quantum mechanics, relativity, dark energy. Perhaps there is another surprise waiting, a way around the horizon that our current theories do not encompass. I do not want to raise false hopes. Everything we know suggests the horizon is absolute. But the universe has surprised us before, and humility requires admitting that our knowledge is incomplete. The future is not fully determined by our current understanding. Regardless of what the far future holds, the present is ours. The universe is showing itself to us right now, revealing its secrets while revelation is still possible. We are the fortunate generation, the consciousness that can know the truth while the truth is still knowable. Let us not waste this privilege. Let us look up at the stars with wonder. Let us study the cosmos with rigor. Let us share our knowledge with each other and with future generations, and let us appreciate the magnificent prison in which we are blessed to exist. Now, as our journey draws to a close, I want to leave you with some final reflections on the nature of our cosmic situation. We are stardust contemplating the stars. Every atom in your body was forged in the heart of a star or in the violent explosion of a supernova. You are the universe become aware of itself. a local concentration of matter and energy that has achieved the remarkable feat of consciousness. The same laws that created the cosmic horizon created you. The same expansion that imprisons you gave birth to you. You are not separate from the cosmos. You are the cosmos, temporarily organized into a form that can wonder about its own nature. We are prisoners who understand their prison. Most inmates never truly grasp the nature of the walls that confine them, but we have understood. Through centuries of observation, theory, and experiment, we have decoded the architecture of our cosmic jail. We know why the horizon exists, how it works, and what it means. This understanding is itself a kind of freedom. The walls remain, but they no longer oppress us through ignorance. We see them clearly, and in seeing them, we transcend them in the only way that matters. We are witnesses to a fleeting moment. The universe will not always reveal itself as it does now. The evidence of the Big Bang, the billions of visible galaxies, the accelerating expansion, all of this will eventually be hidden from future observers. We are living in a cosmic springtime, near when the universe is young and bright and full of discoverable secrets. Someday winter will come, and the cosmos will fall silent. But we are here now in the springtime, and we can see the flowers bloom. We are meaning makers in a universe that has no inherent meaning. The cosmos does not care about us. It has no intentions, no purposes, no values. The same laws that create beautiful galaxies also create black holes that devour everything that approaches. The same expansion that reveals the universe to us also carries it away forever. There is no cosmic plan, no divine purpose, no ultimate significance written into the equations of physics, and yet, we make meaning anyway. We find beauty where the universe offers only indifference. We create purpose where the cosmos provides only causality. We love each other in a universe that does not love anything. This is the human triumph, the act of rebellion against meaninglessness that defines our existence. And so, as we conclude, I want you to carry these truths with you into your life. The cosmic horizon is real. Nothing can escape it. The physics is clear. The mathematics is rigorous. The conclusion is inescapable. We are bounded beings in a bounded universe, and that will never change. But within the horizon, everything is possible. Every star you can see, every galaxy you can observe, every wonder you can imagine, all of this is within your cosmic domain. The horizon limits you, but also defines you. It tells you what your universe is, and that universe is vast beyond comprehension. The universe is showing itself to you right now, in this moment. The light from distant galaxies is entering your eyes. The cosmic microwave background is passing through your body. The evidence of the Big Bang is all around you, waiting to be studied and understood. This is a gift that future generations will not receive. Treasure it. The time you have is finite, but it is enough. You will not live to see the heat death of the universe. You will not live to see the last star die. You will not live to see humanity become a galactic civilization. But you will live long enough to wonder, to learn, to love, to create, to experience the miracle of consciousness in a cosmos that mostly consists of dead matter and empty space. That is more than enough. That is everything. So look up at the stars tonight. Know that they are calling to you across the void, that their light is a message from the past, that their present existence is forever hidden. Know that you can never reach them, never touch them, never visit the worlds that orbit them. Know that the cosmic horizon surrounds you, defines you, imprisons you for all eternity. And know that none of this diminishes you. You are a witness to the universe. You are a maker of meaning. You are a consciousness that has understood its own cosmic situation. You are the universe contemplating itself, and that is the most remarkable thing that has ever happened in all of space and time. The horizon is waiting. The cosmos is watching. The stars are shining. And you, small and finite and mortal and bounded and beautiful, are here to see it all. This is why nothing can escape the observable universe's horizon. This is the physics, the mathematics, the cosmology of our cosmic prison. But this is also the poetry, the philosophy, the meaning of our cosmic existence. The prison is real, but so is the freedom we find within it. The limits are absolute, but so is the wonder they contain. The end is coming, but so is every moment between now and then. Thank you for joining me on this journey to the edge of everything. I hope you found it enlightening. I hope you found it moving. and I hope you found it worthy of the cosmos we share. Subscribe to this channel if you want to explore more mysteries of the universe. Leave a comment telling me what moved you most about this exploration. Share this video with anyone who has looked up at the stars and wondered what lies beyond. Together, we can appreciate the universe while appreciation is still possible. The observable universe's horizon is the boundary of all you can ever know. But within that boundary, knowledge is infinite. The horizon is the edge of everywhere you can ever go. But within that edge, the journey never ends. The horizon is the limit of everyone you can ever reach. But within that limit, connection is still possible, still meaningful, still precious. Nothing can escape the observable universe's horizon. But everything within it is yours. Look up, wonder, understand, and live. Because the universe gave you this moment, this place, this mind, this heart. It gave you the ability to see the stars and to know that you can never reach them. It gave you the capacity to understand the horizon and to accept its absolute finality. It gave you the gift of consciousness in a cosmos mostly devoid of consciousness. Do not waste these gifts. The horizon is watching, the stars are waiting, and you, Lord Cosmic Prisoner, Cosmic Witness, Cosmic Miracle, are alive. For now, that is enough. That is everything. And with that thought, our journey concludes. Not because we have exhausted the subject. The cosmic horizon contains infinite depths that we have only begun to explore. But because we have reached a natural resting place, a moment of synthesis and reflection, a point where understanding and feeling converge into something like wisdom. The universe is vast. The horizon is absolute. The future is unknown. But you are here, you have listened, you have wondered, you have understood. Thank you for that. Thank you for being a consciousness that cares about these questions. Thank you for being part of the cosmic community of minds that contemplates the nature of existence. Thank you for looking up at the stars and asking why. The horizon cannot take that from you. The expansion cannot erase your curiosity. The heat death cannot undo the meaning you have made. You have existed. You have wondered. You have been part of the universe's awakening to itself. And that, my friend, is a triumph that no cosmic prison can contain. Until next time, keep looking up. Keep wondering. Keep asking the questions that matter. The universe is listening. The horizon is watching. And the stars, ancient and silent and impossibly far, are waiting for your gaze. Give it to them. They have earned it. And so have you. End.